Here we're going to talk about using identities to find the values of trig functions. Now here I've written a few identities. The first three identities, these top three, are what we call Pythagorean identities. So Pythagorean identities. And the bottom two here are examples of what are called reciprocal identities. So reciprocal identities. Now there are other identities out there, of course, but these are the ones that commonly get used when finding the values of trig functions. Let's see some examples of problems I'm referring to. So let's find sine of an angle if cosine of the angle is given to be 3/5, and we're also given that the angle is in quadrant 4. So now they give us the value of cosine, and I'm asking myself, how is sine related to cosine? And you could handle this problem a couple of different ways, but if you want to use identities, remember that from the identity we saw on the previous page, we have the square of sine plus the square of cosine is always equal to 1. And that's true for any angle, okay? So you don't have to know what the angle is, but for any angle, take the sine of the angle, square it, add it to the square of the cosine of the angle, and you're always going to get 1, which is really interesting, right? So in this case, we're given that cosine of the angle is 3/5. They don't tell us what the angle is, but they just tell us that cosine of the angle is 3/5. So I can go ahead and write that in here, right? So I've got sine squared theta plus, now remember, this is the square of cosine, and cosine is 3/5. So this is the square of 3/5, and that's equal to 1. Okay, so that means that sine squared theta plus, well, 3/5 squared is 9/25. That's equal to 1. And then if I subtract 9/25 from both sides, I get sine squared theta is equal to 1 take away 9/25. So that sine squared theta is equal to, it's going to be 16/25. Now, this isn't sine, this is the square of sine on the left-hand side. To isolate the sine, you have to use the square root property. Now, when you do that, that's going to generate a little plus or minus. So this becomes sine of theta equals plus or minus the square root of the right-hand side. Right? It's not just the square root of the right-hand side, it's plus or minus. Now, you have to decide which of these you want, and that's why we need some more information. And the information, the second piece of information is given that the angle, right? We don't know what the angle is, but we do know that theta is in quadrant 4. Now, this is quadrant 1 right in here, quadrant 2, quadrant 3, and quadrant 4. And I know that in quadrant 4, I know that sine of the angle is less than 0. And that's because the sine of the angle always has to do with the y-coordinate, y over r. And in quadrants 3 and 4, the y-coordinate is negative. So sine is negative in this quadrant. Now, going back over here, I say, oh, that means that, you have to choose plus or minus, positive or the negative, and we're going to choose the negative because of that. So that means that sine of the angle, sine of theta, is negative, and you should simplify this if you can, right? The square root of 16/25 is 4/5. So sine of theta is -4/5, and that would be our answer. Okay, so notice that we solved this problem by making use of this identity, the Pythagorean identity. Let's try another one like that. So let's find secant of an angle if the angle is in quadrant 3 and tangent of the angle is 5/4. So once again, I ask myself, oh, can I think of an identity that connects tangent to secant? And we can. It's that 1 plus the square of tangent is equal to the square of secant. This is an important identity as well. The previous identity was important. You should definitely have that memorized. And this is another one that's worth memorizing. It comes up very often. So I can see that this identity connects tangent to secant, right? And I have tangent, so I'm going to substitute it in here, and that's going to leave me with secant. So tangent of theta is 5/4, so I get 1 plus, well, it's the square of 5/4, right? And that's the square of secant. So I get 1 plus 25/16 is equal to the square of secant. So let's write that in the following way. Secant squared, right? Just write that on the left. And then when I add these together, I get, well, 16/16 plus 25 over 16 is going to be 41/16. And then once again, use the square root property. So we've got secant of theta is positive or negative, the square root of the right-hand side. And I have to do two things, right? I have to simplify this if I can, and I also have to choose between the positive and the negative. So using this other piece of information, that is the angle is in quadrant 3. And quadrant 3 is right here, right? And I know right here that secant of theta is less than 0. And I know that because I remember that cosine is less than 0 in this quadrant, right? And secant is simply the reciprocal of cosine. So if cosine is negative, secant is negative as well. Okay, so I'm going to choose the negative, and I get secant theta is equal to the negative of, well, I'm going to take the square root of the numerator and denominator separately, and I'm going to get the square root of 41, but then the square root of 16, of course, is just 4. So this would be my answer. I have no idea what the angle is, but I know that secant of that angle is equal to this, given that information. Okay, let's try one more that illustrates a really delicate point for us. Let's find the values of cosine of an angle if we know that tangent of the angle is 4/3 and sine of the angle is less than 0. So looking at this right away, the first thing I notice is that I'm looking for cosine, and they tell me about tangent, right? Now you have to be really careful with this. You might jump right to this, that tangent of theta is equal to, you know that's 4/3, but you also know that tangent is always equal to sine over cosine. And you might mistakenly just say, oh, sine of theta is equal to 4 and cosine of theta is equal to 3. That's not true, right? Even though sine of theta over cosine theta, even though this has got to be 4/3, let me write that down. Even though sine of theta over cosine theta is 4/3, it's not necessarily, well, it's not true that sine of theta is 4 and cosine of theta is 3. Now that's never true. I can tell that's incorrect because sine of an angle, remember, is always less than or equal to 1 and greater than or equal to -1. That is, sine of an angle always lies between -1 and 1. So you can't simply say, oh, cosine of theta is equal to 3 and I'm done with this problem. We have to do something else. So what we're going to do is this. There's not a direct identity connecting, there's not a direct Pythagorean identity connecting cosine and tangent, but there is one connecting tangent to secant, right? So I want to make use of tangent somehow, and I know that from what we saw in the previous example that 1 plus the square of tangent is equal to the square of secant. Okay, and that's going to allow me to get secant, and then I can make use of the fact that cosine is the reciprocal of secant. So I've got 1 plus, let's see, square of tangent is going to be, we're going to square 4/3, and that's the square of secant. And I've got 1 plus 16/9 is the square of secant. So once again, I get secant squared, and it's going to be, well, when I add these together, I get 25/9. Okay, that's 1 plus 16 over 9. Now we're going to make use of the square root property. So secant of theta is positive or negative, the square root of 25 over 9. Now once again, we have to decide between the positive and the negative, so we need more information. And this is the information that we haven't yet used, right? Sine of the angle is negative. Now you might say, well, how am I supposed to connect that to this? And what we're going to do is we're actually going to think about tangent for a moment, right? Tangent is 4/3. Let me write that again right here. So tangent of the angle is 4/3. Now it is true, as we noticed, that tangent of theta is sine over cosine, and that's always true. Now if sine of theta, right, that's right here, if sine of theta, that is this numerator, if that's less than 0, right, well, tangent is 4/3, and 4/3 is a positive number. But if this is negative, right, and this divided by that is a positive, that must mean the denominator is negative as well. Did you see that? Sine over cosine has got to be, at the end of the day, 4/3, a positive number. But if sine of theta, if we're told that it's negative, right, that means the denominator's got to be negative as well. So that a negative divided by a negative gives a positive. Okay, in this case, positive 4/3. So what we conclude is that cosine of theta has got to be less than 0. Okay, but if cosine of theta is less than 0, That implies that secant of theta is less than 0 as well, because secant of theta is simply the reciprocal of cosine. And that means that secant of theta is negative, right? I chose a negative here from this, 5 over 3. Okay, and then finally, cosine is simply the reciprocal of secant. So it's negative 3/5. Okay? And notice that this is between -1 and 1, which is a condition that always has to exist on the values of sine and cosine. Okay, so that's how we use identities to find the values of trig functions. Until next time.